Hope you've had a lovely day. Today our topic of discussion is financial mathematics. This is a topic you have learned since grade 9, if you remember, grade 10, 11 and 12. So with financial mathematics, we deal with financial growth, where we deal with the simple interest and the compound interest, and the formula for simple interest is the first formula at the top of the document, followed by compound interest, where P represents the present value of the investment or the loan, A being the accumulated amount or the future value, N is the time period, R is the interest rate as a percentage. Then the graphical relationship between simple and compound interest. Compound interest is represented by a curve graphically, and simple interest is a straight line. Then we have financial decay or financial depreciation. Of course, you know, in reality, when you buy a property, for example a car, the more you use it, it loses value, so it depreciates, and by the time you sell it, you won't get the same amount of money as what you use when you were buying the car. And the graphical relationship between linear and the reducing balance depreciation is represented by the graph. Hope you can see the graph on your screen. Now let's talk about the present value annuity. In a present value annuity, a sum of money is normally borrowed from a financial institution and paid back with interest by means of regular payments at equal intervals over a time period. The loan is said to be amortized. Amortized means pay off, when it, together with interest charges, is paid off. The interest is calculated on the reducing balance method, and that's the formula for the present value annuity. So every time you are dealing with a loan, that is the formula you're supposed to use. So question one of our activity number 3. Tepo takes out a home loan over 20 years to buy a house that costs 1,500,000 rands. It's a loan. Calculate the monthly installment if interest is charged at 10.5% per annum. So it's a loan. We use our present value formula. So P equals X square brackets 1 minus brackets 1 plus I to the power negative n over I. The loan is 1,500,000, and we are looking for the X value. 1 minus 1 plus our I is 10.5% monthly, so it's compounded monthly, to the power, so 20 times 12, that gives you 240 months, so to the power of 240, but negative, close brackets, over 0.105 out of 12. Some of you struggle to get the value of X here, and it's a problem of algebra. Let me show you how you're supposed to go about this. So you cross multiply by the denominator, so that means you have 1,500,000 times our 0.105 over 12. Then after you divide by our big bracket, and that big bracket starts with a 1 minus brackets 1 plus 0.105 over 12 to the power of negative 240, and that gives you the value of X. So that's how you punch it into the calculator, and if you do that, you get your X your X value is 14,975 francs and 76. So that's how much SSIP has to be paying every month in order to settle the loan. Then question 2, calculate the outstanding balance immediately after 144th payment was made. The balance outstanding. So we have two approaches to calculating the balance outstanding. One, we calculate the present value of how much is left to be settled, and in that case we use the present value formula. So outstanding balance equal to x into 1 minus brackets 1 plus I to the power negative n over I. But now in this case your n is the outstanding payment. Outstanding payment. The outstanding payment. Remember, you're supposed to make 240. But then after 140, how many payments do you have left? So that means it would be 240 minus 144. And that gives you your value of 96 payments. Your value of 96. So you have 96 payments outstanding. So we have our value of x from the top, which is 14,975,70 brackets 1 minus brackets 1 plus the interest rate is still the same, 0,105 divided by 12, now to the power of negative 96 divided by 0,105 over 12, and you punch that in your calculator. It gives you 969,927,74. Alternatively, you could work out the accumulated amount of the loan for the first 140 payments. Loan is 1,500,000. The interest is still the same, to the power of 144. And once you do that, the accumulated value of the loan will be 5,259,229.61. So that's the accumulated amount of the loan. Then 2, you have to work out the future value of the loan after 144 payments. So we use our f equals x into brackets 1 plus I, the power n minus 1 over I. Monthly it's 14,975,70, then brackets 1 plus 0,105 over 12 to the power of 144 minus 1 over 0,105 out of 5, and the future value of the loan in that case will be 4,089,302.47. So after, we need our outstanding balance. The outstanding balance will be the difference between these two amounts. So outstanding balance will be your 5,259,229.61 minus your 4,289,302 7, and that should give you a value of 969,927,114. So that's how you would approach the question. And when you look at the two values, there's a slight difference in the value. That is due to the round of errors here and there. So let's go to question number 2. Let's go to question number 2. Question number 2 says, a business installs a server for 500,000 rands. The value of the server depreciates at 20%. Depreciates at 20% per annum according to the reducing balance method. Calculate the scrap value of the server at the end of 6 years. So scrap value, we have to use the reducing balance formula. A equals P brackets 1 minus I to the power N. The original cost of the server is 500,000 brackets 1 minus the depreciation rate is 20% to the power of 6, and that will definitely give you 131,072 rands. So after 6 years, the server will be worth 1,031. Then you go to question 2.2. Question 2.2, which is still part of question 2. The server needs to be replaced after 6 years. Calculate the cost of the new server if the inflation rate is at 7% per annum. The older server will be traded in. So how much will it cost the business? First of all, let's calculate the price of the new server, and with inflation we use the compound interest formula. The old server was costing 500,000. The inflation rate is 7%. For over the same period of 6 years, this gives us 750,365,1759. Why am I not rounding off to 2 decimal places? Because this is not my final value. But anyway, if you want, you can still go ahead and round it off, and that gives you 118. But then the old server will be traded in. So if it will be traded in, that means the business does not have to pop out the entire 750,365. It just have to top up on the old server. So if you subtract the value of the old server from what the new server would cost, how much would it cost for the business to top up? So that's what the question really wants. So the cost of the new server would be our 750,365,18 minus the scrap value of the old server, which is 131,072, and that gives us an amount of 619,293,18. So that's how much it will cost. That's how much it will cost the business to get a new server. Hope we are moving together. 2.3. On the day the server gets installed, meaning on day 1, the business sets up a sinking fund into which equal monthly installments must be paid. So a sinking fund, it's a savings fund. Just imagine yourself wanting to buy something, and then you have that tin in your bedroom or in your cupboard or even under your bedroom. So every single coin you get, you drop into the tin. You sink the coins into the tin. Why are you doing that? You're doing that to save for the future. So that tells you that the sinking fund is actually, it's a future value annuity where you're making equal monthly deposits. Hope you get it. Interest on this fund is 8% per annum compounded monthly. The first payment will be made immediately. Remember, immediately, and increases by 1. Let's see if there are no any changes. And the last payment will be made at the end of the 6-year period. So at the end of the 6-year period, that means our N increases by 1. 6 times 12 gives you 72 plus 1. That means N will be 70. N will be 73. Hope you get that. Calculate the value of the monthly installment into the sinking fund. So you ask yourself, how much do I need to have in the sinking fund? The amount you need to have in the sinking fund should be the cost of the server, which is 619,293.18. That's how much you need to have into the sinking fund, because that's the amount you need to top up onto the old server in order to get the new server. So that's the technicality in the question. So the formula F equals X into brackets 1 plus I to the power N minus 1 over I. So in the future, we need to have 619,293.18 into the sinking fund, where we make a monthly payment that we don't know how much. Brackets 1 plus the interest is 8%, that is 8 divided by 100, divided by 12, compounded monthly, because you need to get the interest every month, to the power of 73, then minus 1, close the square brackets, over 0.08 over 12. Now we are back to the algebra of finding the value of X. So your X here, for those of you who struggle, you're going to have your 619,293.18 times the denominator that's on there, your 0.08 over 12. Then after, you have to divide by the brackets, which is 1 plus 0.08 over 12 to the power of 73 minus 1. And once you do that, you get your value of X as 6,613.64 rands. So that's how much the business needs to be depositing into the sinking fund if we are to have a new server in 6 years' time. 6.2, the business decides to rather pay a monthly installment of 15,000 into the sinking fund. So instead of the 6,000, they are opting for 15,000. After how many months will there be more than 1 million in the sinking fund? So you have to ask yourself, how long does it take for them to have 1 million in the account? How much will it take them to have 1 million in the account? So it's a monthly payment of 15,000, so it's an annuity. We're still using the same formula. We need to find out how long will it take to have 1 million as the future value. If every month we are depositing 5,000 into the same account for the same interest rate, compounded monthly. to the power of n minus 1 over 0.08 out of 12. So n is an exponent, so you need to know that we need to work with the logarithm somewhere, somehow. So you simplify everything. Remember, you cross multiply and then divide. If you remember the algebra, you cross multiply first, then you divide. So this will be the division, that will be cross multiplication, and then after you transpose the 1 goes as a plus. So if you do that, this is what you'd get. You'd have 1 million times 0.08 divided by 12 over 15,000, but then plus a 1. The 1 is just independent, it's not part of that. Plus a 1, and that would equal to your 1 plus 0. Let me get a better space. Sorry about that. Let's get a better space. Okay. Hope we'll manage. So this will give us our n as equal to log to the base of 1 plus 0.08 over 12 of the 1 million. I hope that's a million, 1 0 short, times our denominator fraction 0.08 over 12 divided by the 15,000, but then plus a 1 somewhere here. And when you do that, you get your n as 55,3423758. So it will take 55 months and some days in order for the account to have a million. Remember, the question is asking after how many months will there be more than a million. So that means it will be therefore after 56 months. After 56 months, we'll have more than a million into the account. Okay, we got activity 4. Activity 4 is basically activity 2 and activity 3, the present value annuity and the future value annuity. But then we are comparing investments, or we are comparing options. So our question one here says Andile wants to borrow money to buy a motorbike that costs 55,000 rands. He plans to repay the full amount over a period of 4 years in monthly installments. He is presented with 2 options. Option 1, the bank calculates the total amount that Andile would owe after 4 years if he borrows 55,000 rands for 4 years at a simple interest rate. So option 1 deal with simple interest rate of 12.75% per annum. Andile then pays the total amount back in equal monthly installments over the period of 4 years. So option 1 is simple interest. How about option 2? He borrows 55,000 from the bank. He repays the bank in equal monthly installments over 4 years. The first payment will be made at the end of the first month. The interest is charged at 20% per annum compounded monthly. So option 2 deals with interest compound interest, whereas option 1 deals with simple interest. So question 1.1.1, if Andile chooses option 1, calculate his monthly installments. Remember, option 1 is simple interest. Option 1 is simple interest. So we need to calculate how much is accumulated by simple interest. The simple interest formula, A is equal to P brackets 1 plus I N. The loan is 55,000 to 1 plus. The simple interest rate is 12%, 12.75% times 4 years. And this would be 83,050 rands. But the question is asking us for the monthly installment. So that means we shall have to divide our 83,050. We have to divide it by 48 months, and this will give us 1,673.67 rands every month, and that is the answer. So this is monthly. 1.1.2, which option is the better option for Andile? Justify your answer with appropriate calculations. With option 1, Andile will have to pay back a total of 83,050. Now let's see how much will he be able to pay if he chooses option number 2. If he chooses option number 2. Option number 2, interest is earned monthly and is expected to pay equal monthly amounts. So we shall need to work out the value of x. It's a loan, so we are dealing with a present value formula. So that means we use our formula P equal to x square brackets 1 minus curved 1 plus I to the power negative n, close the square over I. The loan is 55,000 equals x into 1 minus brackets 1 plus the interest rate compounded is 20% divided by 12 to the power of negative 48 months, close square 0.2 divided by 12. Still the algebra part, I'll do it for you. X would equal to the 55,000 times our denominator of 0.2 over 12 divided by the entire bracket, which is 1 minus brackets 1 plus 0.2 over 12 to the power of negative 48. So that gives you the monthly payment of 1,673.67. Actually, we need to go back to question 1.1.1. The monthly payment is not 1.6. Sorry about that. It's a human error. The monthly payment is supposed to be 1,730.21. So when you compare the monthly repayments, option 1, every month Andile is supposed to be paying 1,730, whereas option 2 is supposed to be paying 1,670.73. So you can see that in option 2, Andile pays less every month. So that's what it gets in option 2. The question again, which option, sorry about that, Which option is better option for handling? Justify your calculation. Then 1.1.3, calculate the interest rate for option 1. Oh, okay, it's okay. So from the calculations here, you can see that with option 1, with option 2, he'll be paying less monthly payments for over a period of 48 months. That means option 2 is the better option. So therefore, option 2 is better. Why? Because he pays less monthly as compared to option number 1. 1.1.3, calculate the interest rate for option 1 that will ensure that the same monthly installment is paid in both options. So with option 2, we need to calculate how much does he actually pay back. So that means we shall get our 1673.67 multiplied by the 48, and that gives us an amount of 80,336.16. That's what he pays back in option 2. And if you compare it with option 1, it is less, because option 1, the total amount is 83, but in option 2, the total amount is 80. So using option 1 formula, the compound formula, rather the simple interest formula, A equals P brackets 1 plus I N, with the amount of 80,336.16 would equal to, P is still the same loan, 5,000. We are looking for I, then times 4. So you divide by the 50,000, the 55,000, that gives you 1,460657,455, and this should equal to 1 plus 4i. You transpose the I, rather you transpose the 1 and divide by 4. That leaves you with I as equal to 0,11516. Then you multiply by 100, that gives you 11.52%. So that's how much interest rate that should be charged in option 1 if at the end of the day Andile would be paying the same amount with both options. And then the last subsection, that is question 1.2, and that would be our last question, 1.2. Lindway receives a bursary of 80,000 for her studies at university. She invests the money at a rate of 13.75% per annum compounded yearly. She decides to withdraw 25,000 at the end of each year for her studies, starting at the end of the first year. Determine how many full years this investment will finance her studies. So at the end of each year, so every year Lindway withdraws 25, and Lindway got a bursary. So when you get a bursary, it's like receiving a loan. Okay, you get all the money, the 80,000. So from the 80,000, every year you have to deposit or to chop or to withdraw. If I use chop, maybe you can get to chop 25,000 from the 80,000. Okay, so already the 80,000 is there, it's available. So you are deducting from the 80,000 every year, you're deducting 25,000. So you look at it in a present value annuity situation. So our formula is P equals X into 1 minus brackets 1 plus I to the power negative N over I. The amount at hand is 80,000, and every year we deduct 25,000. 1 minus 1 plus. The interest is compounded yearly. The interest is compounded yearly. So 0,1375 to the power of negative n. Just a moment. Okay, candidates, interest is compounded yearly, so meaning our n is a year, and every year is 25,000. So this is fine. Over I 0,13775. So you go through the dynamics of using your logarithms. I'll leave that as a challenge to you, but then make sure that the n you get is 4,50054779. Of course, when you round off, it's 4,5. The question is asking for how many full years. So how many full years? So that means that therefore she'll be able to withdraw for 4 full years. And that's where we end. Candidates, I hope you've benefited from this video. This is just a tip of the iceberg of the many questions. So try to find those past exam question papers and practice, and make sure that every time you're tackling the question, you understand what the question really wants. All right. Thank you so much. God bless you, and bye.